take you to the practice quiz. Do problems 1A and B. And we're going to have a short class today. Just going to go until 1 o'clock. And then we'll take a 15-minute break. The exam opens up at 1:15. It was originally set to go from 1:15 to 2:15, but I extended it for 15 more minutes. 1:15 to 2:30. And the instructions on the exam, I'll repeat this right before we break, but to take the exam just like you would take it if it was in class. You can use a non-graphing calculator. You can't Google things. You can't use your notes or look at examples. Can't look at the online textbook or physical textbook. Okay. And I noticed lots of take-home portions of the exam are there, and uploaded. So the first one is 4 to the 3/2 power. And then also do part B. I'll give you just 30 seconds more. Okay, let me have you stop. All right, we had gone over something similar to this in the previous practice quiz. And let me just review some of the ideas. If I had 4 to the 2nd, we all know that that's 16. But that's really 4 to the 2 over 1. And so the top part of this fraction is making the 4 bigger, up to 16. The bottom part is just keeping it the same size and just leaving it at 16. When you have 4 to the 2 over 2, the top part would still be doing the same thing the top part is doing over here, making the 4 increase to 16. But we know 2 over 2 is 1, so the bottom part must be taking that 16 and turning it back to a 4. The only way it could do that is if it's a root. So we put an arrow and we show that that one comes out, this other one stays. So this would be the square root of 16. You don't have to write the 2 out there, it's implied when you don't write it, which gets you back to 4, which we knew had to be. So the top number is the exponent, trying to make the 4 grow. The bottom number is the root. So this 2 is going to come out. It's going to be the square root of 4. Now the top one, cubed, we can either cube it inside or we can delay it. Doesn't matter. And it's going to be easier to work with smaller numbers. So I'm going to square root first, and I get 8. The next one is a negative exponent. We talked about this last time as well. When we have negative exponents, the result is not a negative answer. It's fractional. You get this. And we talked about it, is when you have positive exponents, you keep doubling. So if you go in the opposite direction, you must be going by half, because the pattern must stay the same. 2 to the 0 must be half of this. 2 to the negative 1 must be half of that. So if moving down doubles, moving up's got to take half of it. And you keep doing that and you get to the negative third equals 1/8. All right, give me a little feedback on A and B. Nailed it or still working on it? Still working on it? Give me details about which one's harder. Type that up, don't hit enter quite yet. Tell me if you still need to be reviewing this or you got it all set. Okay, go ahead and hit enter. Okay. And all right, since today we have a very short time for the new section, I'm going to jump right in. Radicals and rational exponents. Let me just check. I'm going to remove the worksheet for today, but it's still up. What worksheet are you talking about, Beverly? Or does anybody else know a worksheet on inverse functions? Still up, but we don't have to do it. I tried to remove it. I remember right after class I went and tried. Let me write myself a note. I'll remove it again. Remove inverse homework worksheet. You do not have to do it. I will remove it again. Somehow it didn't take when I did it before. Alright, so let's go here. So we have some problems here. Identify as true or false. And normally I'd be putting you into groups and checking in on you, but we got such a short time today. I'm going to kind of run through this. 3 plus 19 is 22. That's a true statement. 12 minus 4 is 9. No, it's supposed to be 8, so this is false. And so equations can be true or false. And let's look at this one. Is this true or is it false? My first instinct is, oh my gosh, it's the same numbers on both sides, so this has got to be true. So I'd start to write true, but then something inside of me would say, oh, let's check it out though. The square root of 4 on the right side is 2. Square root of 9 is 3. And this side, I can't do it that way. It says you have to, it's all inside one square root, so it's an implied parenthesis. You've got to add the 4 and the 9 together and you get 13. And then take the square root. So this is asking, does 2 plus 3 equals the square root of 13? Well, 2 plus 3 is 5, and square root of 13 is smaller than 4, because square root of 16 would be 4. So somewhere between 3 and 4, this is false. Alright, now, this is something really important about the topic for today, radicals. There's a radical sign, and if you put the radicals, and notice how many terms are inside the parenthesis. There are 2 terms. If there's more than one term, if we divvy up the radical to the 2 terms, we get a false statement. So let's go and look at the next one. Alright, this one, I'm just as comfortable as I was last time. I'd put true right away, but I gotta check it out. let's check it out first. And alright, square root of 4 is 2. Square root of 9 is 3. 2 times 3 is 6. Now on this side, you got to do what's inside the radicals first. 4 times 9 is 36. Square root of 36 is 6. Does that equal each other? Yes, this is true. Now here's the big deal. Inside the radical, it's one term. Alright, when you have just one term inside the radical, remember terms are separated by addition, subtraction, or equal sign. One term inside a radical sign, then you can divvy up the root to each part of it, and you'll still get a true statement. But if it's more than one term, and you divvy up the square root, you get a false statement. Now let's go to these. E. My guess might be, maybe, when it was addition, it was false. So I'm going to guess this one's false. Let's see if I'm right. Square root of 25 is 5. Square root of 9 is 3. And I get 2. And then this, 25 minus 9 is 16. Square root of 16 is 4. Does 4 equal 2? Absolutely not. This is false. Alright, so again, it's consistent. When you had two terms inside the radical, if you divvy up the radical or the root to both parts, you get a false statement. And this one, it's one term. I'm going to guess that this one is going to be true. Well, let's check it out. 2 times 3 is 6. Square root of 36. I think we already did this one. This is true. When, again, it's one term, you get to divvy it up into the different parts. G. Can I divvy this up and will it work out the same in both cases? Well, I noticed that it's one term. Inside. So it's still one term. So I'm going to guess that it's true. The right-hand side is 3. Square root of 25 is 5. The left-hand side, you have to think of it all at once. What fraction times itself will give you 9/25? Well, 3/5 times 3/5 gives you 9/25. And this is true. Again, when you have one term, you can divvy up the radical to the different parts. So let's go down to number 2. Generalized rules for roots. We're going to complete these. Square root of a times b. Since it's all one term, you can divvy it up into the square root of a, square root of b. And this one, since it's all one term, we can divvy up the square root to each part. But here is really important. If you do this, you are wrong. And if you do this, you are once again wrong. If it's more than one term, you cannot do this. You just leave it. There's nothing else you can do. Can't break that apart. All right. Now, we're comfortable with the rules in the abstract for working with radicals. We're going to work with radicals like this. We'll have instructions to simplify square root of 75. Now, if I saw square root of 75, my first impulse would be, well, I'm going to punch it in my calculator. And I'll get this big 8.66 something. And isn't that simplifying? Well, we don't call that simplifying because this, in theory, is exact. And this is not exact. The calculator chopped it off. Although it might only have that many digits, this really goes on forever without ever stopping. So this is called an approximation. It's not the exact same as this. So it couldn't be simplifying. And we call that approximating. So we don't mean punch it into a calculator. We mean something else. So we simplify square root of 75. And how not to simplify? I might be tempted to say 75 is 25 plus 25 plus 25. But look what I'd be doing if I went from here to here. I would be doing C. I'd be rewriting 75 as 25 plus 25 plus 25 and then divvying up the square roots. And this is not allowed. This doesn't check. If you take the square root of each of these, you get 5 plus 5, 15. 15 times 15 is 225, not 75. Fails to work because of C. So now, let's see how we're really supposed to do it. How do I simplify square root of 75? I want to use property A up here. And so how we do it is we break it up not into things that add to 75, but things that multiply to 75. And there's something special about the 25. The 25 is what we call a perfect square. Perfect squares are perfect square like 4, 9, 16. These are perfect squares because there's something squared. Alright. Now, notice that it's okay to divvy up the square root. This is property A. And then, since this was a perfect square, it comes out of the square root, and we write it like this. Now, this, giving the answer like this, you don't have to put a dot, but this is bad form. Why it's bad form is because a lot of people make their square root sign really sloppy. And suppose you wrote it like this. Now look at that 5 is kind of halfway inside the square root, halfway outside. Does it belong inside the square root or not? You can't tell. And even when you're writing like this, if you rewrite it again, you might accidentally extend this bar a little bit too long. Alright, so the better format is put the number first, the square root at the end. And then it's super clear. This is not in the square root, that one is. And we wind up getting so many expressions like square roots of 75 and square root of 3. It turns out that, like, suppose you had square root of 75 divided by, let's say plus plus square root of 3. Now, the square root of 75 we just figured out is the same as 5 square root of 3 plus square root of 3. And there's an unwritten 1 in front of this. It's kind of like 5x plus 1x equals, think of the x as being square root of 3, 6 of those. So, this kind of thing, why we simplify it is because if you had this, you could condense it a lot to this, but you wouldn't know unless you took the square root of 75 and simplified it as much as possible. Alright, so this is the kind of stuff that you're going to see in this homework set, is to simplify things like square root of 75. Now, I'm going to do another one. Let's call it C. Go to a different color. Square root of 20. Now, let's look at the way we did it before. We put the perfect square number in the back, but then we eventually had to turn it around and put that perfect square number up front in front of the square root. So, we'll go a little bit quicker if we break it up into two things that multiply together, but the one that's a perfect square we're going to put up front. And what perfect square is a factor of 20? It's 4. 4 times 5. And then the perfect square number comes out of the square root. And voila, that means the same as that, but it's in a simpler form. Any questions? Okay. Let me do one D. Just as soon as you think you got the hang of it, I'm going to throw a crazy one in here. Cube root of 16. Now, alright. We're going to break this up into two things that multiply together. My first impulse is to write perfect square. But that would be wrong. It's not a perfect square. We need a perfect cube. Now, what do I mean by perfect cubes? 1 cubed, 2 cubed, 3 cubed, 4 cubed. 3 times 3 is 9, times 3 is 27, 4 times 4 is 16, times 4 more is 64. These numbers are perfect cubes. Okay, do we see one of these as a factor of 16? Yes, 8 times 2. And then the cube root of 8, what number times itself 3 times will give me 8? It's 2. Like this. And let me give you another problem. We talked about, that was, I think, D. Let's go to E. We did fractional exponents. And we did negative exponents, both of those in the practice quiz. But what we haven't done is, what if they're both combined? It's a negative fraction exponent. All right, the easiest way to tackle these is handle the fraction, the negative part first. Anything with a negative exponent, bring it down to the bottom, and you make it a positive exponent. Because negative exponents don't give you negative results, they give you fractional results, small fractional results. And then we do this like we know how to do it. This comes out in front. So we get cube root of 8. Now, this is going to get squared, but remember, it's just one term. Because it's one term, I get to play with the order. I could put the square here, but then I'm going to get a really big number that I take the cube root of. If I wait and square it later, that's also an option, and I'll have smaller numbers to work with. So then, the cube root of 8 is 2 squared, and my final result is 1/4. Okay, and last one. Converting from one form to another. If I have, let's say, the cube root of y to the 12th. This is in radical form. We can go back and forth either way, whichever we like. I'd say, all right, what if it was in fractional exponent form? Remember how we took the bottom part of the fraction and we said it comes out as the root? It could also go in the other direction. This comes in here. So this becomes 12 over 3. And then this is y to the 4th. And from radical form to fractional exponent. And sometimes we like it in one way, or sometimes we prefer it in the other way. This one reduced really nicely when I changed it to fractional form. If I had, we can have other examples in the reverse order. All right, the homework, so we're at 1 p.m. The homework is this section, which is 1.3. And when you're in the modules in 1.3, let me just point out, control find 1.3. Okay, it tells you your normal stuff, and then it also says, here's some extra problems on this worksheet. So notice that as well. So your typical stuff, but then some extra problems there. And we will take a break now. And the exam, you will find that in the modules as well. Let me go to Student View, Modules. If you go down to Module 4, Inverse Functions, way at the bottom, you see Exam 1, click on this. It says it's locked until 1:15, so in about 15 minutes you can start on it, and it will allow you, it's actually until 2:30. I extended the time a little bit more. Any questions?
Mr. Shankin, this is Beverly. The exam is something that we can print out and then email in, right? Or do on separate paper. It's not on the computer.
You have options. So yes, once you can get into this, so let me come back here. Leave student view. Yeah, once you're looking at the exam, you'll see it's, I'll go in right now and I'll show you. As an instructor, I can open it up. It's a PDF file. You could print it out, or you could just write number 1, A, here's my answer, and then you can then at the end, take images of what your work and then send that in. Or you could print this out and write your work right in these spaces right here, and then upload this. Your option. Is it clear, Beverly?
Yes, thank you.
You're welcome.
I have one more quick question, actually.
Yes.
When should we see our grade for the exam?
I'll be grading it over the course of this weekend, so it'll definitely be up before we have class again. Okay, you'll have your grade at least before Tuesday. Hopefully much sooner than that, but it depends on many other factors. Okay, but I'll guarantee that it'll be up before class on Tuesday. Anything else? All right, good luck on the exam. Again, the instructions on taking the exam are do it as if we were physically in class and I was walking around, and I'm only allowing your a non-graphing calculator, no books, no pencil, can't look up things on the internet, and can't look up examples. I will see you all Tuesday. And I'll, if any questions come up during the exam, every now and then I'll check in on either on Discord and or on my email. And you could either put it up in Discord or send me an email.